Okay, so we have this x squared equal to 7 times the integer part of x minus 5, and we want to find out all such x that works. We split up x into I plus f. I is the integer part and f is the fractional part, and we quickly realized that I plus f whole square, if it is equal to 7 times I minus 5, because this is I, then I square must be less than or equal to 7i minus 5, because this is less than or this is greater than I square. If you expand this, you will see it is greater than I square. And by the way, recall, we also showed that I is greater than 0 in the previous video. So this particular inequality works. Alright, now if we look at this particular inequality, we know exactly what to do. And this is a little bit of quadratic equations that you need to know, or quadratic inequalities that you need to know. Because if you bring everything to one side, you have I square is less than 7i plus 5, which is less than 0. You are bringing everything to one side, and you want to know for what values or for what integers this will work. So if you do not know how to find that out, here is a way to do it. You set this equation equal to 0. You find the roots of this quadratic. So I is equal to 7. So you use the quadratic formula. 7 is 49 minus 25 by 2. So this is I is equal to 7 plus square root of 29 by 2. I'm sorry, this is 20. Okay. Square root of 29 by 2. Or I is 7 minus square root of 29 by 2. Of course, none of these are integers, so really no integer will be equal to these two. But that's not our goal. We want to know when is this less than or equal to 0. So it is less than or equal to 0 if I is between these two values. 7 minus square root of 29 by 2 and 7 plus square root of 29 by 2. Why? Well, that will need a little bit of work from quadratic inequalities, which we do not have the space to discuss here. This is just a problem discussion. So look up quadratic inequalities if you do not know why this is true. And this value is approximately 7 plus 6 over 2, which is 13 by 2, which is 6.5. Why? How do I approximate this? How do I approximate this? Well, I know that square root of 29 is definitely less than square root of 36. So I can replace this by 6, which is the nearest square, and still get a larger number. So 6.5 is definitely larger than I. And this is very good because we have to just check for integers up to 6 now. Starting from 1, because we know that I is greater than 0. So starting from 1, if we check up to 6, that's it. No other integers greater than 6 will work. In the sense, if an integer is greater than 6, then this inequality will not work, and then the entire problem breaks down. So you can now check. This is possible to check by hand because obviously there are very few integers. So let's do that. So we can check by hand for I equal to 1, 2, 3, 4, 5 and 6. These are the 6 things that we have to check. And what do we need to check? Well, we need to check whether x square equal to 7i minus 5 has a solution or not. Okay, how do we check that? That's easy. Plug in I equal to 1. So if I is equal to 1, we know that x square is equal to 7 times 1 minus 5, which is 2, or x is equal to square root of 2. In the previous video, we have shown x is positive. So x is square root of 2, and it works because Square root of 2 is 1.414 approximately, and box of that is 1, which is exactly what we needed. Okay, so 1 of the x square is 2. Great. Let's try plugging in I equal to 2. So x square equal to 7 times 2 minus 5, which is 14 minus 5, which is 9, which implies x is 3, but that doesn't work because then box of x is 0, which is not the same as this one. So x equal to 3, x equal to 2 does not work. Okay, let's try x square equal to 7 times 3 minus 5. So what if I is 3? So then it is 21 minus 5, which is 16. Again, we have the same problem because then x is 4, box of x is 0. It doesn't work because we want box of x is equal to 3. Okay, so 2 and 3 does not work. Let's try our luck with 4. So x square is equal to 7 times 4 minus 5, which is 28 minus 5, which is 23. That's good because if x squared is 23, square root of x is between 4 and 5, right? Because x squared is between 16 and 25, which means box of square root of x squared is between 4 and 5, which means box of x is 4, which is exactly what we needed. So x squared equals to 23, that works. So x squared equal to 23 works. Very nice. Next, we have to check 2 more. X squared equal to 7 times 5 minus 5, which is 35 minus 5, which is 30. That's good because if x squared is 30, then x is between 5 and 6 if x squared is 30, and that is good because then box of x is 5, which is exactly what we needed. So x squared equal to 30 works. So let's put that up there. X squared equal to 30 works. And finally we have x squared equal to 7 times 6 minus 5, which is 42 minus 5, which is 37. And again, that means box of x is 6, which works because that's what we needed here. So we have x squared equal to 37, that also works. So, and that's all we have to check because these are the 6. X cannot be greater than, or I cannot be greater than 6. So we know that. So we just add up these numbers because we need the sum of those, and that's 92. So 92 is the final answer. Notice that this problem is beautiful because of many reasons. One of the reasons is that we learned how to use box functions in tricky problems, and we also learned how to use growth rates of functions to solve challenging problems. So keep on doing great mathematics. Link in the description will take you to more problems like this. Thank you.